Hey, what is up, guys? Carter here. Today's lab is all about hydrates. Now, a hydrate is a compound made up of a molecule bound to water. In the molecular formula for hydrates, this composition is represented by that dot you see. It just means that for every molecule of CuSO4 copper sulfate, there is a certain number of water molecules bound to it. Our job in this lab is to figure out what that ratio is, or in other words, what is the value of X. To do this, we're going to figure out what percent of the hydrate is water. After measuring the initial mass, we're going to heat up the hydrate so that all the water evaporates, leaving us with the final mass that is just the copper sulfate. We can then use the final and initial masses to find the percent water by mass of the hydrate, and ultimately, we can use moles to figure out what X is. So, let's get started. Our first step is to find the mass of an empty evaporating dish. First, grab a clean evaporating dish and the blue copper 2 sulfate from the center of the lab, and head over to the balance. Place the empty dish on the scale and record the mass displayed. Next, we're going to tare the balance and add about 2 grams of hydrate. So press tare and grab a scoopula. You can find a scoopula either in the center of the lab or in one of the drawers at your bench. Use the scoopula to carefully add about 2 grams of the hydrate. It's really easy to add way too much, so be careful. If you do add too much, do not put it back in the container. That would contaminate the hydrate sample. Since we've already tared the balance, add until the monitor reads about 2 grams. Don't worry if it isn't exactly 2.00. Just make sure to record your initial mass. Now it's time to heat up the hydrate using a Bunsen burner in order to evaporate all of the water. A Bunsen burner uses a continuous stream of gas to keep a flame going. To light the gas, you are going to use a striker. To use the striker, use one firm stroke like this. Don't brush it back and forth. That will wear down and damage the striker. To turn on the gas, the lever needs to be turned 45 degrees. So now it is on. You can adjust the height of the flame by rotating the dial at the bottom of the burner. So turn on the gas, light the burner, and slide the burner underneath the stand with your dish on top. Use the scoopula to spread the hydrate evenly across the bottom of the dish. Heat until the solid turns grayish white. That tells us all the water has evaporated. If you see dense white fumes, stop heating right away. In that case, not only is all your water gone, but you're now decomposing the salt. As you can guess, that isn't good. All in all, the heating should take about 3 minutes. Once you're done heating, turn off the gas and use a glove to remove the dish. Make sure you remember that glove. The dish is still pretty hot. Step 4 is to find the mass of the dish with the white solid. Let the dish cool down for about 5 minutes, and then place the dish with the white solid on the scale and record the mass. When doing our calculations, remember that your final mass is equal to the mass of the dish with the white solid minus the mass of the empty dish. Our last step is to clean up. Make sure you dispose of the white salt in the special waste container labeled CuSO4 waste. That's it for this lab. Good luck, guys.
Thanks, Carter. There's not much more for me to add, but I do want to offer a brief summary. Here's our chemical reaction that we are performing. We have a blue hydrate, and remember the hydrate still has the water molecules loosely bound in the crystal. When we heat it, the water of hydration is driven off to the atmosphere, leaving behind an anhydrous salt. And note the terminology here. Without the water, it's an anhydrous salt. Without water, and salt is another word for an ionic compound. And the hydrate has the water and is blue at the start of the reaction. Stop when all the blue is gone. Do not go to the point of heating where you start seeing fumes or smoke coming up from your crucible. That means you've overheated the sample. Data to record that was mentioned by Carter in the video: the mass of the dish, the mass of the hydrate. Try to use about 2 grams of the hydrate. Doesn't have to be exactly 2, but as long as it's within plus or minus 10% of that, you're pretty good. mass of the dish plus the anhydrous salt at the conclusion of the reaction. So this is all data points that you need to make sure you get. Calculations to do are very similar to the homework we've assigned. You need to calculate the percent by mass of the water in the hydrate to the appropriate number of significant figures, the value of X to the appropriate number of significant figures, and the most likely formula of the hydrate, acknowledging that X is probably not an integer value, but we need to have an integer value, obviously, because we can't have fractional water molecules. Good luck.